Okay, this is question 3, the inverse function question, and they start up and they tell you that f of x is equal to the square root of ax. But they give you a point. They tell you that when x is 8, f of x, or y, is equal to 4. So what do? Well, we just put in 8 for x and 4 for y. If we square both sides, we get 8y equals 16. Well, that means that a must equal 2. So we know that our function is y equals the square root of 2x. Okay, state the domain of this function. What are all the things that x can be? What are that? Well, we know that x has to be positive because you can't take the square root of a negative number. So x is greater than or equal to 0, but x is an element of the real numbers. Well, how do we do the inverse? Well, what do? Well, the first thing we do is we write down the function, and then we switch x and y. We square both sides, we divide by 2, and we get y equals 1/2 x squared. There's the inverse in the form y equals. All done. Now we're going to sketch this function y equals root 2x and y equals 1/2 x squared on the same set of axes. Well, the easiest one to sketch, well, I guess this one's pretty easy. If I put 2 there, the square root of 4 is 2, so 2 and 2 is a point. If I put in 0, I get 0, so I know that 0 and 0 work. So you might try 0 and 0 work in both functions because you switch x and y and it works. Then if I put in 1 here in the inverse function, the inverse of that, if x is 1, y is 1. That's in the inverse function. So then the square root 1 must be the opposite. I should be able to switch x and y instead of 1/2 and 1, make it 1/2. Well, what happens when we sketch these two? What does it look like? Well, one's a parabola, y equals 1/2 x squared, a happy parabola, 0 and 0, 1/2. And if I put in the next number, 2, I get 2. And if I put 2 in here, the square root of 4 is also 2. That's where they happen to cross each other. And the inverse function, the line y equals x, is the axis of symmetry. The inverse is like a parabola on its side. And where y is greater than 0 and x is greater than 0, we're looking at the same section up here. That's what makes it all work. So what if you wanted to find out where they cross and you weren't too sure? What would you do? Well, you take the line y equals x and you make it equal 1/2 x squared. Well, we multiply everything by 2, we subtract 2x, we factor. We know they cross at 0 and 0 and 2 and 2. So there you go. The whole thing's done.